Now, it turns out it's not enough to just run the regression model and then start using it to make predictions. We need to make sure that the regression model we have is good, that it's a good fit for our data. So we're going to use these goodness of fit measures, which Excel gives us very easily, to help interpret which model is the better model. So if we think back to our data that we've looked at, we've used two models. The first model we looked at just used income level to predict debt payments. The second model used income level and unemployment to try to predict debt payments. Now, we've already talked about how given the p-value, which we're going to come back and talk about more in the next video, but the unemployment may not be a good measure of debt payments. And so it may turn out that just adding more variables to our regression model doesn't necessarily make it more predictive, especially if those variables don't really have very good predictive value. If unemployment is not a good predictor of of debt payments, then we wouldn't want to include that. That's just including noise. So there's really two or three goodness of fit measures we're going to look at. The first one is the standard error of the estimate. So we've got this really ugly formula here, but Excel gives it to us real easy. But the standard error is going to be between 0 and infinity, but the closer to 0, the better. In fact, the standard error measures the amount of basically how much of the dispersion, if you think about that scatter graph plot, how much is the dispersion away from the line due to that residual epsilon or that residual E? So in other words, how much of that dispersion is captured by our model and how much of it is due to other factors that we haven't included yet. So the closer we get to 0, the better we have done at creating a model that truly captures what causes the independent variable to react the way it does, or gives us a better prediction of what the independent variable will be. So again, Excel gives it to us. It's in the regression statistics portion, and it's called the standard error. Now, we're going to look at that here in a minute because there's standard error in another area, and so I want to make sure that you pay attention. You might want to highlight, star, underline in your notes that it's in the regression statistics portion. Now, another one we're going to look at is called the coefficient of R squared. And again, this has got a very nasty formula here, but it's looking at how much of the equation can be explained, or how much of the variation can be explained by the linear regression model. So it falls between 0 and 1, and the closer to 1, the better fit. So if we have 100, we can say 100% of the independent variable is explained by the regression model. Of course, we're never going to get exactly 100%, but the closer to 1 we get, the better. Now again, Excel gives us this. They also gives us this thing called the multiple R, and that is, again, looking at if you have multiple independent variables, it's looking at how well between all of them they contribute to the explanatory power of the regression model. Now, there's one problem with the R squared, that is you can't compare different models that have different numbers of independent variables. So for example, in our case, when we're trying to figure out is it income or is it income and unemployment that affect debt payments, we could not use the R squared coefficient. We would have to use what's called the adjusted R. And so the adjusted R adjusts for the extra variables that are input, because R just says more variables better, but more variables aren't necessarily better. So we use the adjusted model to compare between the two. And so again, that adjusted model allows us to compare between different models that have different numbers of independent variables. So if we're going to jump back over and look at our data here just a minute in Excel, but I want to point in mind we're trying to decide between model 1, which is just looking at income, or model 2, which is looking at income and unemployment. So let's jump back to Excel for just a moment. So here I've got my data pulled up again. Now I'm going to run my Excel, my regression analysis here in Excel, and I'm going to run it two ways. So the first way I'm going to run it is going to be using just model 1, so just the income data. So I'm going to say my X variable is just C1 through C27. My Y variable is still B1 through B27, and everything else stays the same. So here we get our data for this first one. Let's just kind of move everything around here. Now again, as I was pointing out, there's a standard error over here in column H, but that's not really what we want to look at. We're looking at this particular standard error here. This is the one in the regression statistics portion. Sorry, I was trying to highlight for a minute. And then we're going to look at our R-square model. So here we can say our R-square model tells us that approximately 75.26% of the variation in debt payments can be explained by this particular model, which uses income. Now I'm going to do the same thing again, but I'm going to run the analysis using both variables now. So again, I'm going to change my X range to not just be C1 through C27, but D1 through D27. And I want to change my output range, and I want to make my output range F21 down here. Let's just put this right below. So now I have my statistics here for under the 2 model, model 2, and I can see my standard error is 64.61. And I can see that my R squared is 75.27. So again, very close to what it was earlier. Now remember, we can't compare these two, but what we can compare is this adjusted square. So I see the adjusted square on model 2 is 73.12% versus 74.23%. So if I notice on model 1, my standard error is smaller at 63 versus 64, and my adjusted R squared is higher at 74% versus 73%. So given our data, we could conclude that model 1, just using income, is a better predictor of debt payments than income and unemployment. Now that's not to say that it's a great predictor by itself, because notice our standard error is still 63. That's pretty big. So we know that there's still a lot of things that affect debt payments that are not being included in this regression model, but it turns out that unemployment isn't one of the things that we would want to include in this model.